Hello guys, welcome again to mathematics learning video with me, Miss Diana. Okay, in this video we're gonna continue to do completing the square. This is the part 2 of completing the square. Now in this part 2 we're gonna look at example 2 and example 3, how to express the quadratic expression into perfect square using completing the square method. Okay, now this is the question for example to express 2x squared plus 10x plus 7 in complete square form, and then find the factor, vertex, axis of symmetry, and the greatest and the least value. Okay, now first thing first, we have to write this expression into equation by make it equals to 0. So 2x squared plus 10x plus 7 equals to 0. Okay, now the second step for completing the square, actually this second step wasn't in the previous video or wasn't in the previous example. The second step is to make sure that a equals to 1. If a is not 1, that we have to make sure that a equals to 1 by dividing all the elements here by a. So in the first video or in the first example, actually this step wasn't there. Why? Because the a has been equal to 0. So in this example, actually a equals to 2. So we need to divide by a. A in here is 2, so we divide by 2 all the element here. So we have x squared plus 5x plus 7 on 2 equals to 0. Then we continue to the next step, which is to move this c to the right side, or in another word, we subtract both sides with 7 on 2. So here x squared plus 5x equals to minus 7 on 2, like this. And then another thing, we need to add both sides with a half of b squared. So plus b over 2 squared. In here also 5 on 2 squared. Remember, if we treat the left side by adding with something, then we have to treat the right side with the same thing, because we just want to change the expression, not change the value. Okay, after that we're gonna change this into the perfect square, because we have add both side with half of b squared, then it is just simple to transfer this into the perfect square, which is this is x squared, then we just take x here. This is 5 on 2 squared, we just take 5 on 2, and then in here we just put a positive sign like this, and then this is a minus 7 on 2 plus 25 on 4. Okay, I'll continue in here. Okay, in here we have x plus 5 on 2 squared equals to, okay, now here we just need to multiply this by 2 and multiply this by 2 so that we can have the denominator equals to 4. So minus 14 plus 25, and then we have the denominator is 4. In here we have x plus 5 on 2 squared equals to 11 on 4. Okay, this is actually the perfect squared expression. Now the last step is we just need to put this to the left side again. So x plus 5 on 2 squared minus 11 on 4 equals to 0. So this is the perfect squared expression from this quadratic equation or quadratic expression. This is the things that we have got before, that the perfect squared expression of this quadratic expression is x plus 5 on 2 squared minus 11 on 4 equals to 0. Then the next thing, we are asked to find the factor, the factors. Then the next thing, we are asked to find the factor. What is the factor? The factor is x equals to what? So in here, actually, we can move here to the left side. So here x positive 5 on 2 squared equals to 11 on 4. The next thing, because we want to find x equals to what, then here we have to make this square disappear. How to make it? Just by take the square root of both sides. So in here we have x plus 5 on 2 equals to the square root of 11 on 4. And remember, if we take the square root of this is the result of this is positive minus. Okay, the next thing, we just need to move this 5 on 2 on the left side, because the things that we want is x equals to what? X equals to positive minus the square root of 11 on 4 negative 5 on 2. This is actually the answer, or you can simplify more this 4. You take the square root of 4, x equals positive minus the square root of 11 on 2 positive 5 on 2. So this is the final answer of the factor of this expression. Okay, now the next thing, we are asked to find the vertex. I'll rewrite this: x plus 5 on 2 squared minus 11 on 4 equals to 0. Okay, now remember the standard form of this is x minus a squared plus b equals to 0. A and b is the vertex. So for the vertex is a comma b. The vertex is minus 5 on 2 comma minus 11 on 4. This is actually the vertex of this quadratic expression. And then the other things about the axis of symmetry. Axis of symmetry, it is the x coordinate of the vertex, which is x equals to minus 5 on 2. Okay, the next thing is about the greatest or the least value. Remember, we can see the greatest or the least value based on this value of y, because it is also depend on the vertex. So in here, because we have a equals to positive number, which is positive 2, then actually the shape of the parabol will be smile parabol like this. So between the greatest and the least value, this parabol has the least value. So the least value is y equals to minus 11 on 4. So this is the answer for example number 2. Okay, let's continue to example number 3. In this example number 3, actually the same kind with the example number 2, express this quadratic expression in complete square form, and then find the factor, the vertex, axis of symmetry, and the greatest or the least value. Okay, in here, actually we have to write this in order, start from the highest degree to the constant. So we have to put this in order first: minus 12 x squared positive 7x plus 12. Now we have an ordered expression of quadratic. I'm gonna make this equals to 0. Okay, the first thing first, we need to look at the value of a. If it is not 1, then we have to divide all the element with a. So in here we have minus 12, so we have to divide this with minus 12. In here we have x squared, and then minus 7 on 12, because we divide with minus 12x, and then minus 1 equals to 0. Okay, the next thing, we need to put this c value to the right side. So we add both sides with 1. X squared minus 7 over 12 x equals to 1. Okay, then we add both sides with half b squared. So, okay, now plus minus 7 on divided by, if this divided by 2, then the denominator will be twice 24 squared, and then here also plus minus 7 on 24 squared. Okay, now let's do this one by one. And after this, here we wanna transfer this into the perfect square like this, because we have add both sides with half of b squared, then it is just simple to transfer this into this perfect square, which is just take from this x and just take from this is minus 7 on 24. Okay, just that simple. And then for the right side, we have here 1 plus 49 over 576. Okay, now let's continue in here. Now in here we have x minus 7 over 24 squared. Then we simplify this, 625 over 576. Okay, now the next thing, we want to try to find the factor. The factor, we just want to take x here. X equals to what? Okay, then we will make this squared disappear first by taking the square root of both sides. So in here, x minus 7 on 24, and then here the square root of 625 over 576. Don't forget to put a positive minus sign here. And then after that, we just need to move this to the left side. So x equals positive minus the square root of 625 over 576 plus 7 on 24. This is the factor. There are two factors here, which is the first factor, you just take the positive sign here, and for the second factor, you just take the negative sign here. So this is the factor of this quadratic expression. Okay guys, this is the perfect squared expression or equation that we have got from completing the squared. Okay, the next thing, we're going to find the vertex. Okay, remember the standard form of this is x minus a squared, and then positive b equals to 0. Okay, then the vertex is a comma b, so the vertex here is 7 on 24, comma, minus 625 on 576. So this is the vertex coordinate of this quadratic equation. That is the vertex. And how about the axis of symmetry? Axis of symmetry is the x coordinate of the vertex, which is x equals to 7 on 24. And then for the greatest or the least value, okay, look at this. This is the value of a equals to minus 12. If the a is in minus number, then we have an open downward parabol, then we'll have the greatest value. So the greatest value here, we just take from this the y value of the vertex, which is y equals to minus 625 on 576. So this is the vertex, axis of symmetry, and also the greatest value of this quadratic expression.